channel, and you might probably wonder what we're doing today. We are looking into variation, and variation has to do with variables. And if you remember very carefully, you can have variables whereby you deal with x, y, n, and even mixed variables. So what are we doing for today? Let's see. One, the first part of variation is direct variation. The second part is inverse variation. The third part is joint variation. And the last part is partial variation. I'll be taking it one at a time so that it will be so clear to my viewers. But the first one I'll be dealing with today is direct variation. Let's take that first. So what exactly is direct variation? Direct variation is basically based on two variables. And variables could be x and y, like I said, m and n, and any of the good variables. So let's take a question. If x is directly proportional, to y, when x is 2, y is 4, find x when y is 16. I mean, this question is so easy. If x is directly proportional to y, when x is 2 and y is 4, find x when y is 16. Good. What do? We say x is directly proportional to y, so that makes this x equals ky. Now, one thing you should understand that in variation, whenever a proportionality sign is removed, you get equal to and a constant. So first, let's make k subject. That will be k equals x over y. Now, what are the first set of values? The first set of values are 2 and 4. So that will be k equals 2 over 4. 2 here 1, 2 here 2. So k equals to 1 over 2. I've gotten my constant as 1 over 2. The question now is, how do I get the last part, which is x unknown and y is 16? So what you just simply do here, you say, coming back to this connecting relation or law of variation, it also actually came from this direction. This is x equals ky. So from here, you can say to get x, that will be x equals k is 1 over 2 times 16. 2 here 1, 2 here 8. X equals what? 8. You can see how simple this is. It's way so simple. Thank you so much. So let's take one more question on variation. Alright, let me take this one. Now, particularly external exams, what white students should expect, or what the kind of questions they might likely bring is, if x is directly proportional to the square root of, or to the square root of 81. Or let's do it like this. If x is directly proportional to the square root of 81, or probably, instead of us even using that, we can say that if x is directly proportional, this is so common, proportional to the square of y, and you see this, when x is 3 and y is 81. find y, I've reversed it now, the other time was x. Find y when x is 27. I mean, this is a way straightforward question. Look at my question. X is directly proportional to the square of y when x is 3 and y is 81. Find y when x is 27. That's also straight. Now, x is directly proportional to the square of y. So that will be x equals ky squared. Right there. X equals ky squared. That's our connected relation. So if you make a subject, making k subject will be what? That will give you x over what? That will give you x over, okay, let's probably make this 9. So our values will not be too bulky. That will be what? X over, our x first set of values is what? 3. And your y square will be what? 9 squared. So that will be k equals 3 over 81. 3 here 1, 3 here 27. So k equals 1 over 27. You see this? Now the statement is, how can we get y from the connecting relation or law of relation? That will be, coming back to the second phase, find y when x is 27. X is 27, remember we are using x ky squared. X is 27, k is 1 over 27, and this is what? Times y squared. I say this. Very, very straightforward. We are looking for y. That will be 27 equals y squared over 27. I say this. When you cross multiply, y equals to 27 by 27. Now, if you look at this so closely, you see that 27 by 27 is so straightforward, 9, 4. And of course, this is 18. And this is 4, we have 1. So this virtually gives you 5. And so this is 9 to, well, that's 7 to 9. If you have 7 to 9 as y, that means y squared equals to 7 to 9. What's the square root of that? So that means y equals to 27. So when x is 27, y is as well 27. Thank you very much. God bless you. See you in my next class that will have to do with inverse operation. Bye.